Here I have two examples dealing with rotations. The first one is I'm going to go to the coordinate grid and I want to rotate a point, in this case 7, -3. I want to rotate it 90 degrees counterclockwise about the origin. So the first thing I'm going to do is I'm going to plot the 2 points that I'm working with. The first one is going to be at 7, -3. Should be approximately there. Let's get the coordinates out there. And then my center rotation is going to be the origin. There we go. Now I could grab my compass and my protractor and my straight edge and go through and rotate this. However, what I'm going to do is I'm going to think about, if I'm on the coordinate grid and I have to rotate something 90 degrees, well, that means that I have segments that are going to be perpendicular or raised. So this one side of my angle of rotation, I can see the other one has to be perpendicular to it. Well, I start thinking about what do I know about lines or segments in the coordinate grid that are perpendicular? I know that their slopes are opposite reciprocals. So I look at this one, the slope of that segment is going to have a slope of, well, it goes up 3 and left 7. So the slope would be -3/7 for that part. Well, then my other one's going to have a slope of +7/3. Now you have two options here. You can either go kind of this route, so that one, now I'm going to fix that so it looks like the way it's supposed to, or I could go this route. Either one is going to have a slope of +7/3. But now what comes into play here is the counterclockwise. So I have to ask myself, well, which ray or which segment here, the green or the red, would give me an example of a rotation that's going counterclockwise? The answer to that is going to be the green because, as we see, it's going counterclockwise. Now let me get rid of all this stuff and actually put it in there. So what I look at now is I'm going to start at my point 0, 0. There's my center of rotation. I have to get a segment or a ray that's going to have a +7/3 slope. So I'm going to go up 7, and I have to go over 3. So I'm going to have a ray that looks something like that. And if everything's done right, I can look at that and it looks like a 90-degree angle. I should be able to get a protractor out and measure it. It'll be a 90-degree angle as long as your coordinate grid is 1 by 1 squared. So now it's just remembering back to, now that I have my angle there, now I just have to get the distance. So however far it is from the origin to 7, -3, I have to find that equal distance from the origin up to my other point. And the way I look at this is, well, if I go 7 to the right and down 3, is that going to be any different than going up 7 and right 3? Answer is no. So then I have my point here at 3, 7. I've rotated my point 90 degrees counterclockwise, and my image is going to be right there at 3, 7. So it's one way to do it. You could, like I said, use your protractor and compass, and you'd end up with the same exact point. Now another one is this one, where I want to know, does it appear, and keyword here, and this one is appear, because remember I always try to tell you not to trust your eyes, but I'm going to go with, what does it look like? So does it appear that this star has rotational symmetry? And if it does, we want to find the order and we want to find the magnitude. Now I look at this and I go, well, does it or doesn't it? And I'm going to say, yeah, it looks like it. And what I've done is I've created this so that I can rotate it, and the center's not exactly right on. But when I look at it, I've rotated it, and there it is. It lands right on top of it. I rotate it, it's going to continue to land on top of itself. So what I want to do then is, I want to figure out, so let me answer the first question. Yes, we have rotational symmetry. Now, let's go to I actually like to start with the magnitude. And the way I do that is, just like I did it in the lesson, is find your center of rotation, connect it to some point on your figure. Now, when I rotate it, where does that point end up at? Well, that one's going to end up over here. I connect. This point ends up here. Connect. This point to here. Connect. This one to here. Connect this point back to where I started from, and I have them. Now here I have 1, 2, 3, 4, and 5 angles. And again, if I add up all those, I'm going to end up with 360. Being there's 5 of them, they're all congruent. 72 degrees is going to be my magnitude. I have that done. Now I have to go through and I'm going to figure out my order, which I've kind of already done. How many different ways can I rotate it? Well, there's one. There would be 2. Let's keep going. There would be 3. There would be 4. And being I've already counted 1, I get to also count the one that goes all the way back around. So there would be my final one of an order of 5. So the order is going to be 5. So magnitude of 72 degrees and an order of 5 for my star here that appears to have rotational symmetry. And those are the 2 examples that I'm going to show you, and if you have any other questions on anything else dealing with rotations or rotational symmetry, please ask.